In this video, I'm going to talk about a crucial aspect of functions, which is function notation. When we're writing functions, we frequently name the function. And since we mathematicians can be notoriously uncreative, we frequently name the function f for function. And then we want to discuss what variable can be found in our formula. And to indicate that, we put parentheses x of x. So the f is the name of the function. And the of x part, x is the variable that's in the formula. So let's say I wanted to name a function Mary Beth. Maybe I would call it MB for short. So the name of my function in this case would be MB. And let's say I want my function to have the variable, you know what function I want to have? I'll show you. I want to have the function the third root of 5z squared plus 7, because I love the letter z. So the variable that I'm going to have in here is a z. I would say the top function, you would say f is a function of x, or maybe you just say f of x for short. For the MB function, you could say MB is a function of the variable z, or for brevity, you could just say MB of z and leave out this part here. Okay, so that's what the f of x notation is. It's a really powerful notation if you're using, say you're using a lot of different formulas. Say you're working in business and you're dealing with cost and revenue. Then you might want to have functions c of x and r of x so you can compare the two. Let's say that you have a function for profit, but it doesn't depend on how many items you're making. It depends on time. Maybe you call that P of t. So this function notation is actually a really concise way to refer to longer, uglier formulas without writing them all out every time. Now let's practice what you're going to do with this function notation. So for our first example, let's discuss the function. I'm going to go back to being uncreative. F for function, I'll name it, and I'll use the variable x. So f of x is equal to 2x squared minus 3x plus 7. And I want to find f of 0. The reason I color-coded that is I want you to be able to follow along. This means plug in x equals 0 into your formula. So everywhere I see an x, I'm just going to replace it with some parentheses. So instead of 2x squared, I'm going to write 2 parentheses squared. And minus 3x, minus 3 parentheses, and then plus 7. And I'm going to put 0 in place of all of those x's. I was kind of a chicken. I chose an easy one. So when I simplify this, 2 times 0 squared is 0, minus 3 times 0 is 0, plus 7 is 7. So I had f of 0 equals 7. Okay, when you're writing this in your homework, you're just going to type in 7. But what I want you to understand during the lesson is this. This meant x equals 0 went with y, or the output, of 7. In other words, we had the ordered pair 0, 7. Okay, that'll help us when we do 3.2, just as a foreshadowing. So let's do a couple more. Let's do f of b. So again, everywhere I see an x in my formula, 2x squared minus 3x plus 7, I'm just going to put parentheses. And then I'm going to swap out b with all of those parentheses, into all of those parentheses. So there's not much simplifying like in the previous one. This is 2b squared minus 3b plus 7 is my f of b. Okay, let's try some others that you'll see in your homework. You might see f of negative x. Okay, so everywhere I have an x in my formula, 2x squared, I'm going to write parentheses instead, 2 parentheses squared, minus 3x minus 3 parentheses, plus 7. And into those parentheses, I'm going to put whatever's inside the f of notation, so negative x in each one of those. Okay, simplifying that, because that does simplify a little bit, f of negative x quantity squared is just x squared, so 2x squared. Negative 3 times negative x is positive 3x, and then plus 7. Okay. And then we'll continue putting in a couple more other functions in for the x position. So let's say we did f of 2x. So everywhere I see an x in my formula for f of x, I'm just going to put parentheses. 2 parentheses squared minus 3 parentheses plus 7. And then into those parentheses, I'm going to put whatever's in the parentheses at the beginning, so 2x. So 2 parentheses 2x squared minus 3 times the quantity 2x plus 7. Okay, and then that does simplify quite a bit. That will give me f of 2x equals, let's see, 2x squared is 4x squared. Well, 2x quantity squared is 4x squared, so this would be 8x squared. Negative 3 times 2x is negative 6x, and then nothing happened with the plus 7, so plus 7. Okay, let's do 2 more, and I think I want to give myself a little bit more room here. Let's do f of x plus 3. So everywhere I see an x, I'm going to replace it with parentheses. 2 parentheses squared minus 3 parentheses plus 7, so that I can easily put in x plus 3 into each of those parentheses. Okay, now I do have a little bit of simplifying to do here. So on the side, x plus 3 quantity squared is going to be x squared plus 3x plus 3x plus 9, or x squared plus 6x plus 9. So that will tell me what this is. So multiplying that by 2, I have f of x plus 3 is 2 times x squared plus 6x plus 9, which came from that. And then distributing the negative 3 through, negative 3x minus 9 plus 7. So 2x squared plus 12x plus 18 minus 3x minus 2. And then I'm almost done combining my like terms. F of x plus 3 gives us 2x squared. 12x minus 3x is 9x. And 18 minus 2 is 16. So 2x squared plus 9x plus 16. Okay, we got one more to do. Part F. We're going to find f of x plus h. This, by the way, is the start of a big concept in calculus called the difference quotient. So f of x plus h, I'm going to do it exactly like I've been doing all the other ones. Everywhere I see an x in my formula, I'm going to replace it with parentheses. 2 parentheses squared minus 3 parentheses plus 7. And then into those parentheses, I put x plus h. Okay, so going off to the side, x plus h quantity squared is x squared plus x times h. I want to write that in alphabetical order, so I'm going to make that instead h times x. And then I have a second one, and then plus h squared. So x plus h all squared is x squared plus 2hx plus h squared. So that again goes here. We'll distribute the 2 through. So f of x plus h is 2 times the quantity x squared plus 2hx plus h squared minus 3x minus 3h plus 7. Distributing our negative 3 through. We get 2x squared plus 4hx plus 2h squared minus 3x minus 3h plus 7. Not a darn thing combines. It's the only good thing there, so we are done. I think it would be a good idea to do one more example. So for our second example, let's look at the function g of x equals 3 divided by x plus 4. And I want to do a really similar thing as last time. Let's first just do g of 0. So remember, that just meant to plug in 0 everywhere we have an x. And I'm going to start off doing this exactly the same way I did the others, even though this might be simplistic for the first one. So everywhere I see an x, I'm going to replace it with parentheses. So 3 over x plus 4 will be 3 over parentheses plus 4. And then into those parentheses goes the value that's inside the parentheses, g of 0. So 3 over 0 plus 4 is 3/4. Okay. Let's do g of b. So everywhere I see an x, I'm going to replace it with parentheses. 3 over x plus 4 would be 3 over parentheses plus 4, and into those parentheses goes b. Oh, no simplifying at all. 3 over b plus 4. Okay, let's do the negative x one again. Negative x. So 3 over parentheses plus 4 is going to be 3 over negative x plus 4. And yet again, there's not a lot of simplifying to do. 3 over negative x plus 4. Okay, let's do part D, g of 5x. So 3 over parentheses plus 4 is going to be 3 over 5x plus 4. Okay, 2 more. Let's do g of 3x minus 7. So at first, I'm going to do 3 over parentheses plus 4. And into those parentheses, I'm going to put that 3x minus 7. Okay, oh, there actually is simplifying to do here. So 3x minus 7 plus 4 is 3x minus 3. Ooh, you know what? Since the 3 can cancel with both of the 3's in the denominator, I can make this 1 over x minus 1. Cool. Okay, last one, getting ready for the difference quotient problems. Let's do g of x plus h. So first it's going to be 3 over parentheses plus 4. Into those parentheses, we're going to put that x plus h. And 3 over x plus h plus 4, man, no like terms there. So this is 3 over x plus h plus 4. Terrific. Okay, now let's use that and practice what we call difference quotient problems. Okay, so the difference quotient uses this f of x notation a ton. It is probably the most important way we start Calculus 1. So you're going to see in your homework problems like this. Simplify the following. F of x plus h minus f of x all over h for, let's do f of x equals 3x minus 4. Now, they're not going to necessarily tell you in your homework that this ugly fraction that you're looking at here is the difference quotient, but it is. This is the difference quotient, so I'll call it DQ for short. Okay, and here's what we need to find. We need to find f of x plus h, I guess f of x, but that'll be pretty easy. Here it is. It's 3x minus 4. And we already know h, and then we're going to plug each of those pieces into our fraction and simplify. F of x plus h is going to be the tricky one. So let's do the problem the same way we were doing examples 1 and 2. Everywhere I see an x in the function f of x, I'm going to put parentheses. So instead of 3x minus 4, I'm going to put 3 parentheses minus 4. And into those parentheses, I'm going to put x plus h. So that will simplify to be 3x plus 3h minus 4. Okay, so here we go. Our difference quotient. H is in the denominator. F of x plus h was 3x plus 3h minus 4. F of x was just 3x minus 4. So I took the 3x minus 4 for f of x and I plugged it in here. And I took the 3x plus 3h minus 4 and plugged it in here. Okay, now I just have to simplify. Okay, getting rid of those parentheses. That's going to be 3x plus 3h minus 4, distributing that negative through, minus 3x plus 4, all divided by h, which is going to give us, ooh, a lot of canceling. 3x's cancel. The plus 4 and the minus 4 cancels, so we just have 3h over h. Cool. And those h's cancel. Okay. Difference quotient for this is 3. Cool. Now, I haven't told you what the difference quotient finds you, but we've certainly been able to simplify this one. Let's try 2 more examples for the difference quotient. So for this example, I'm going to change the function. Let's do f of x equals x squared plus 3, but I still want to simplify the difference quotient. In other words, f of x plus h minus f of x all over h. Okay, so we need f of x, we need f of x plus h, and then we need to plug those into that fraction and simplify that. Okay, well, f of x is easy enough. That's just x squared plus 3. And f of x plus h is everywhere you see an x in f of x, put parentheses. So parentheses squared plus 3. And into those parentheses, we're going to put x plus h. So we have x plus h squared plus 3. Okay, x plus h squared. Let's go over here and do a little aside. X plus h squared is x plus h times itself. So x squared plus hx again plus h squared is x squared plus 2hx plus h squared. So that's going to go here. So we have f of x plus h is x squared plus 2hx plus h squared and then plus 3. Okay, so let's plug each of those pieces in to our difference quotient. The f of x plus h goes first. X squared plus 2hx plus h squared plus 3. The f of x goes next, minus x squared plus 3. And then just plain old h in our denominator. Okay, we've done actually the hard part of the problem. Now we just need to distribute our negative sign and combine like terms. So we're going to get x squared plus 2hx plus h squared plus 3 minus x squared minus 3 all over h. The x squareds are going to cancel, the 3's are going to cancel, and what we have left is 2hx plus h squared. Oh, I need room. Let's actually give us even more room than that. Okay, where were we? 2hx plus h squared all over h. And similarly to the last problem, the h's are found in all three of these terms, so they can cancel. So I'm going to reduce this h, and one of those. So we're going to get 2x plus h over 1, which is just 2x plus h. Cool. Okay, let's do one last example. So for our last example, let's do a fraction f of x. Let's do f of x equals 2 over x minus 1. And we'll simplify again the difference quotient. So the f of x plus h minus f of x over h. Okay, so we know f of x pretty well. It's given to us. It's 2 over x minus 1. F of x plus h. Okay, everywhere I see an x, I'm going to put parentheses. So 2 over x minus 1 will be 2 over parentheses minus 1. And into those parentheses, we'll put that x plus h. Okay, well, fortunately, there's not a lot of simplifying that'll happen here. So this is just 2 over x plus h minus 1. Okay, here we go. Let's plug these in. So first one, f of x plus h is going to go in the first spot. So that's 2 over x plus h minus 1 minus f of x. Oh, that was just 2 over x minus 1, all divided by h. Okay. In a fraction problem, we don't have as much foiling out to do, but we do have some denominators to clear away. So here's what we're going to do to clear this, simplify this fraction. We're going to multiply the entire top by x minus 1 times x plus h minus 1, coming from these two denominators. But if you already, whatever you multiply to the top, you also have to multiply to the denominator. So also x minus 1 and x plus h minus 1 multiplied to the denominator. Okay, I need to put some brackets around my numerator because of this subtraction sign. I want to make sure that I multiply both this first fraction and this second fraction by the common denominator. Okay, so here's what that's going to look like. Let me scooch this up a little bit. 2 over x plus h minus 1 will be multiplied by x minus 1, x plus h minus 1, minus 2 over x minus 1 multiplied by x minus 1 times x plus h minus 1. If you're a visual learner, much like I am, you might want to put those x minus 1 times x plus h minus 1s over 1 so that you see that they're in the numerator and they're going to cancel with the denominators. In the big denominator, we just have h times x minus 1 times x plus h minus 1, and not much is going to reduce there yet. Okay, but let's start reducing. So in the first fraction, x plus h minus 1 cancels with the x plus h minus 1, and all we're left with is 2x minus 2. Cool. In the second term, the x minus 1s cancel, and when we distribute the negative 2 through, we get negative 2x minus 2h plus 2. And nothing is going to simplify in the denominator just yet. So h is still multiplied by x minus 1 times x plus h minus 1. But a ton is going to cancel on the top. 2x minus 2x is 0, and 2 plus negative 2 plus 2 is 0. So it looks like, again, giving us some more room here, the numerator simplifies to just negative 2h, and the denominator stays the h that we had originally times the LCD, x minus 1, x plus h minus 1. Now you'll notice I didn't multiply this through because all of my addition and subtraction signs are contained inside parentheses, unlike in the numerator where this subtraction sign is outside of those parentheses. So I left it factored in the denominator, and the reason I did that is because now I can see that the h in the numerator cancels with the h in the denominator. So there's my answer. Negative 2 over x minus 1 times x plus h minus 1. Okay, I need to let you in on a little secret about calculus. Much of the hard part about calculus that you'll take next semester or perhaps the one after that is actually algebra, is this class. In fact, when you get to calculus, what you've been doing here, we call it the difference quotient. If you plug in x equals 0 in calculus, it's called the derivative. It's the basis of the entire first semester of calculus, so it's a pretty big deal. Moreover, plugging in h equals 0 is kind of easy. Doing this work is challenging. So a lot of times my students who are taking calculus tell me the hard part of calculus is actually a lot of times algebra itself. So practice this difference quotient a lot. It's crucial to your first couple weeks of calculus.